Hello, algebra students. Mr. Lawrence here, and if you're watching this video on Monday, I'm very proud of you because it means you prepared for that quest. Some of your classmates had trouble with it, some because they blew off homework and didn't prepare and that kind of stuff, and some maybe because I didn't go over it well enough. But you, ladies and gentlemen, did very well. You got at least a B on the quest. I'm very proud of you. We do have a test coming up later this week, probably on Friday now that I look at things. But anyway, let's get on. You're going to have a little lesson here, and you're going to do some problems and practice. And then in a couple of days, I'm going to be counting on you to teach your classmates how to do this. All right, so make sure you're taking good notes and make sure you can do your best on this. All right, we're going to be talking about absolute value. That's your title for today. Now, absolute value is actually pretty easy. There's a lot involved in it, but it's not difficult. The reason kids get absolute value wrong is they don't understand the definition. So let's see if we've got the definition here, which we do. The definition we're going to use today, and we're going to tighten this up in a couple days because I'll explain something to you a little bit. But for right now, this is a really good definition. Middle schoolers use this definition all the time. The distance from zero on a number line. So if you haven't written that down yet, write it down, highlight it. It is a very important definition. So we can use this to figure out different answers. And it looks like some of my problems have gone. Oh, maybe they're down here a little bit. Maybe I just didn't scroll enough. I thought I put them above my number line. There's my number line, right? Okay, and I want to know the absolute value of 4. Well, the absolute value of 4, let me see. Where is 4? 4 would be 1, 2, 3, 4 would be right here, right? I'm really asking you how many spaces from 0 4 is on a number line. Well, it'd be 4 spaces. So the absolute value of 4 equals 4. Now, the absolute value of negative 3. Well, how far is negative 3 from 0 on a number line? And you guys are so smart. 1, 2, 3. You're going to tell me the answer is 3. And that's awesome. So the absolute value of 4 was 4. And the absolute value of negative 3 was 3. Right? Not negative 3. Positive 3. Distances are always positive. Now, some of you, because you're so smart and you're so used to getting things so quick, you just made up your own definition, and your own definition is wrong. If you just thought, hey, absolute value always makes things positive, you need to forget that because it's going to screw you up. You're not going to be able to do the problems correctly. Okay, I know college students who use that definition and they don't know what the heck they're doing. All right, so let's see if we can apply the idea of how far on a number line a number is to a problem like this one. The absolute value of x equals 2. Okay, what I'm really asking you is, what numbers are 2 spaces away from 0? So I'm going to go from 0 and go 1, 2, and look at that. I'm going to get hit 2. So that means x equals 2. Except, I lost my pen, sorry. All right, x equals 2. There's another answer. Because if I go 2 spaces from 0 in the other direction, I hit negative 2, don't I? So x is going to equal 2, or x is going to equal negative 2. If you're getting absolute value problems incorrect, very likely that you're not considering that there's more than one answer. Many of the problems, when variables are involved, will have more than one answer. We have to consider one on the right-hand side of 0 and one on the left-hand side of 0. Now again, we're going to tighten up that definition because 0 doesn't have to be the center when we do a more advanced problem, but for today we can use that definition. So let's come down here and see if we can do these two problems. Now you're not going to be able to do them in your head. I know some of you are looking at that first one, I can do it in my head, but you're not going to be able to come up with both in your head most likely. So I'm going to show you how to do it. To take an absolute value, the first thing we're going to do is write 2 equations or 2 inequalities depending on what we're dealing with. So the first thing I'm going to write is x minus 4 equals 8. Yeah, that's going to be the first equation I have to solve. Or there's going to be a second equation. This will get me the number on the other side of the center that will be 8 spaces away. Okay, I'm going to write down x minus 4. Oops. Sorry, got out of pen mode there. minus 4 equals negative 8. Do you see that? Oh, excuse me. So I'm going to solve these two equations. And this way I'll get both answers. Like that last problem, absolute value of x equals 2. There were two answers, right? So I'm going to add 4 to both sides. And I'll get x equals 12. And then here I'll add 4 to both sides. And I will get x equals negative 4. I need them joined by an OR. The OR has to be joining them. All right, now let's check that out. Hey, by the way, the center is not 0 on this one, so if you want to test it, the center is actually at 4. So if I'm at 4, how do I know that? Because 4 minus 4 makes 0. See, it turns it into 0. And I go 8 spaces that way. What number do I hit? Well, 12, of course, right? And if I go 8 spaces in the negative direction, well, I go to 0. Oh, I'd hit negative 4, wouldn't I? And look, there are my two answers, 12 and negative 4. They're both 8 spaces away from the center. And the center is 4 in this case because x minus 4, 4 makes that 0. Okay? The point is, it's very, very important, ladies and gentlemen, you need to write two equations or two inequalities. I don't know how many times I can say that. So for this one here, the absolute value of 2x plus 5 equals 12. Well, I'm going to break it up into two inequalities. Okay? And we're going to get 2x plus 5 equals 21, or 2x plus 5 equals negative 21. Again, I go solve these two inequalities. So I'm going to subtract 5, right? And I'm going to get 2x equals 16, and I'm going to divide by 2, and I'm going to get x equals 8. Hey, let me test that. What's 2 times 8? Well, 16. 16 plus 5, 21. Absolute value of 21, 21. Ding, ding, ding. I got it. All right, let's come over here. Subtract 5. Subtract 5. I'm going to get 2x equals negative 26. Then I'm going to divide by 2. And I'm going to get x equals negative 13. I just want to point out to you, do you notice that you don't just get 8 and positive or negative 8. You get two completely different numbers in many cases. Yeah, so you can't just go, oh, I'm going to get 8 and negative 8. I don't have to do both equations. I'm smarter than that. No, actually you're not. You got to do both equations. All right, 2 times negative 13 would be negative 26, right? And negative 26 plus 5 would be negative 21. And the absolute value of negative 21 would be positive 21, and that's what it's supposed to be. All right, so that's doing some equations. All right, so let's see here. Inequalities. Before we do the inequalities, and they're down here somewhere. I know I left them around here somewhere. Inequalities, where are you? There they are. You have to know something. Those equations were done like ORs, correct? Well, inequalities. Sometimes they're done like ORs, and sometimes they're done like ANDs. It's really easy to tell. I'll bet you ladies and gentlemen are so smart, you know what symbol that is. You're going to say less than. But I'm going to correct you, and I'm going to call it a less than. Yeah, if I see a less than symbol, I'm going to do it like an and. Yeah, less than. Get it? And then this symbol is a greater than, but I'm going to do it, excuse me, like a great or. Yeah, so that's a great or. So if I see an equation, it's an or. You notice the ones I did up on the last page were ors. If I see a greater than symbol, I'm going to do a great or. If I see a less than symbol, I'm going to do an and, a less than. All right, so let's test this out. It's done very much the same way as the equations. All right, so I've got an and here. How do I know? Because there's a less than. So I'm going to write 2x minus 3 is less than 6, and 2x minus 3 is greater than negative 6. Yeah, did you notice that? I had to flip the symbol. Okay, this is the long way of doing the and it works really well. I'm going to do this one the long way, and then the next less than, I will do the short way, okay? So, by the way, did you notice I didn't do any operations inside the absolute value? Like, I didn't just go plus 3 here. It would be wrong to do that. Do not do this. This is not sound mathematics, okay? You have to write 2 inequalities, then you can start doing your algebraic manipulations. And so I'm going to add 3 to both sides here. Okay, and we get 2x is less than 9. And then I'll divide by 2, divide by 2, and x is going to be less than 4 and 1/2, right? All right, and, well, I have to add 3 to both sides. Okay, and I'm going to get 2x is greater than negative 3. Divide by 2, divide by 2. And then x is going to be greater than negative 1 1/2. And I can go to a number line and graph this. I have my number line. I'm going to show 4 1/2, right? And I'm also going to show negative 1 and 1/2. Okay, will I have open points or closed points? Well, I believe my points will be open because those endpoints do not make the equation true. It's an and. I'm going to shade in between. Now I can test it. Let's pick a number in here, like say 0. And let's go 2 times 0 is 0. 0 minus 3 is negative 3. Absolute value of negative 3. 3 is 3 less than 6? Yes, it is. Pick a number outside the shaded region, like 5. 5 times 2 is 10. 10 minus 3 is 7. Absolute value of 7 is 7. Is that less than 6? No, it is not. So you see I haven't shaded over there. Okay, let's try this one here. This is an OR. See the great OR? So I'm going to write 2 inequalities. I'm going to write 4x plus 1 is greater than 11, or 4x plus 1 is less than negative 11. All right, I'm going to subtract 1, and I will get 4x is greater than 10. I divide by 4. I'm going to get x is greater than, I believe, 2 and a half. Excuse me, 2 and a half. Or I got to come over here and subtract 1, and I'm going to get 4x less than negative 12. Going to divide by 4. Does that inequality turn around? No, absolutely not, because I'm dividing by 4. I'm not dividing by negative 4. I'm dividing into negative 12, but that's irrelevant. The rule is when I multiply or divide by a negative, I flip the inequality. Okay, so on my number line, let me see here. Let's get a number line going. I've got to show negative 3, right, and positive 2 and 1/2. There's still going to be open points because the endpoints will not make them true because it's not equal to. I need the numbers greater than 2 and a half. Well, they'd be to the right of 2 and a half. And I need the numbers less than negative 3, which would be to the left of negative 3. And there you go. Looks like your typical OR. All right, moving right along like 2 birds of a feather. I've got more problems hiding in here somewhere. I promise I do. They're just a little bit shy. Maybe if you ask them nicely, call problems. Here they are. Okay, now, when we have a problem like these, where we have stuff inside the absolute value and outside the absolute value, the first thing we need to do is get rid of the stuff outside the absolute value. This is not a distribution situation. Did you hear that? Do not distribute here. No, 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 no. We can't add 5 either. We're going to get rid of this 2. How's the 2 attached to the absolute value? By multiplication. So we're going to divide it off. Oh, I gave you a nice ugly number to work with there. Sorry, I guess it's okay. It's not that ugly. And so I'm going to have the absolute value of x minus 5 is greater than or equal to, we'll go 7 and a half. All right? Now, I rewrite it as two inequalities. This is an OR, right? A great OR. So I'm going to go x minus 5 is greater than or equal to 7 and 1/2. Or x minus 5 is less than or equal to negative 7 and 1/2. Yeah, you change the sign of the second one and flip the inequality. All right, so let's see here. Let's add 5 to both sides. So x is going to be greater than or equal to 12 and a half. Or add 5 to both sides. And then x will be less than or equal to negative 2 and a half. All right, so if I go to a number line, a number line, gonna draw me a number line. Yeah, you get a song with your math lesson. Isn't that special? All right, not only am I generous and share all of my $0 with so many of you, I also sing for you too. Off key, I might add. I mean, how often do you get that? Come on now. All right, so I'm going to show negative 2 and a half and 12 and a half. And these points will be closed, right? Because the endpoints are included in the solution. And I need numbers greater than or equal to 12 and a half. They're going to be over here. And I need a closed point there. And I need the numbers less than or equal to negative 2 and a half. And so that's the points over there. All right. So, by the way, you could test it. Again, we could put a number in for x that's in the shaded region, and we'll get a true statement. If we put a number in for x in the non-shaded region, we'll get a false statement, assuming we've done the problem right. So let's test it with 0. Okay, so I'm going to have 0 minus 5, negative 5. Absolute value of negative 5, 5, times 2, 10. Is 10 greater than or equal to 15? No, it is not. Of course not. All right, so you see that work. Now, if you go and test other numbers over here, like if you pick 20, well, 20 minus 5 is 15. Absolute value of 15 is 15. 15 times 2 is 30. And 30 is greater than or equal to 15, right? If you pick one over here, like negative 10, it'll work as well. I'll let you check that out. Okay, so on this one, again, see the negative 2 is not inside the absolute value, so we've got to get rid of it. We get rid of all the stuff on the outside. And then, now we can rewrite it as two inequalities. Now this is a less than, so I'm going to go ahead and write it the short way. Remember I said on the last one I was going to do the long way? This one I'll do the short way. I'm going to write 6x less than or equal to 24, right? But over here, I'm going to go negative 24 less than or equal to 6x. Okay, now normally I would have to add or subtract, but this one doesn't have anything in there. So I'm ready to just divide, and I'll divide by 6. And when I do that, I'm going to get negative 4 is less than or equal to x less than or equal to 4. There you go. And there's the number line. I've got to show negative 4. I've got to show positive 4. This is one of the cases where it ended up being the same number and it's negative. But notice most of them did not turn out that way. All right, we're going to have closed points, right? Now, holy cow, I can't remember. It's an and, but I can't remember which way they go. Well, let's test it. Let's pick a number in this region. And if we get a true statement, we'll shade that region. If we get a false statement, we'll shade away. So let's just pick a number and test in case we're having a panic moment. It's all about testing. Testing that number. 6 times 0, 0. Absolute value of 0, 0. 0 minus 2, negative 2. Is negative 2 less than 22? Less than or equal to? It sure is. 0 gave me a true statement. But you know what? I'm feeling a little insecure, so I'm going to stick 10 in. 10 is not in my shaded region. So 6 times 10 is 60. Absolute value is 60. 60. 60 minus 2, 58. Is 58 less than or equal to 22? Of course not, silly goose. Silly goose, it's not true. Okay, so let's come on over here. And I got one more problem I want to do. And you know what? I think I'm going to actually alter that. I'm going to make that, hold on a second, it's not working so well. I'm going to make that a less than instead of a, oops, wrong button. My wife's here to tell me that we've got to leave soon, but I've got to finish this one problem because you ladies and gentlemen are so special. I have to get this done. So let me go through it quick. All right. I'm going to get rid of the stuff on the outside first. I'm not going to try to manipulate the absolute value or anything. I'm going to get rid of this. I'm going to get rid of the 3 and the 5. I'm going to get rid of the 5 first because it's attached by subtraction, right? So I'm going to have 3 times the absolute value of 6 minus 2x, and that's going to be less than 30, right? Then I'm going to divide both sides by 3, divide both sides by 3, and I'm going to get the absolute value of 6 minus 2x, which is less than 10. And now I need to write 2 inequalities. And I'm going to do this the short way. I'm going to go 6 minus 2x less than 10. And over here I'm going to write negative 10 is less than 6 minus 2x. You do whatever you want there. You can do it the long way if you want. Okay, I'm going to subtract 6 from all 3 sides. And that will get me negative 16. That'll be less than negative 2x, which is less than 4. And then I'm going to divide by negative 2, divide by negative 2, divide by negative 2. Notice how I showed in all 3 places. Dividing by a negative means my inequalities are going to flip. So my answer is going to have this and going to have that. All right, that will be 8, that will be x, and that will be negative 2. All right, I do have to wrap up this video, so I'm going to let you go ahead and graph that solution. And then I'd also like you to write the interval notation for it, please. And once you're done with that, you can get the worksheet and you can work with a partner and practice doing this. Remember, in a couple days, I'm going to have you teaching your classmates how to do it. All right, that's it for the video. Mr. Lawrence signing off. See you later, everybody.